Welcome back class 9 to the online chemistry classes. In the previous class we had already started a new chapter, that is number 4, atomic structure, and we had studied about the discovery of electrons and the properties of cathode rays as well as the properties of electrons. Today we have to continue with the discovery of protons. You know, protons is yet another fundamental particle which is present inside the nucleus of an atom. It is positively charged, and protons are also present in the same place where the neutrons are there, that is in the center of an atom. So atoms are electrically neutral. It means if there are 6 electrons in an atom, there must be 6 positively charged protons also to cancel both the charges and to make the atom electrically neutral. So this realization that there must be some positively charged particles in an atom to make it neutral led to the discovery of protons. In 1886, the name of the scientist who is associated with the discovery of proton, Goldstein, G-O-L-D-S-T-E-I-N, Goldstein, in the year 1886, he is associated with the discovery of protons. Okay, in the year 1886, Goldstein noticed that when a perforated cathode was used in a discharge tube instead of the normal cathode, if a perforated cathode, that is the one bearing pores, was used in the discharge tube, then he found that the rays, another set of rays, were traveling in a direction opposite to that of the cathode rays. So like here the discharge tube is there. Okay, these are the 2 electrodes. Now what he found, that if a perforated cathode is used, some charges travel in the opposite direction, this direction. Cathode rays were traveling in this direction. Now these rays are traveling in the opposite direction. Okay, through this perforated cathode. This one is perforated cathode. Alright. The diagram is already there in your book, also you can check. Perforated cathode. This one is what in the previous one we had seen. One is cathode ray, the other one is anode ray. So he found that the set of rays traveling in a direction, cathode rays were traveling in this direction, that is from left to right. Now they are traveling from right to left, opposite direction. And cathode rays were negatively charged, that is the electrons. Now these are called the anode rays, and they have the positive charges, that is the charge which is present on the protons. So he said these canal rays or anode rays, the rays which were produced and they were traveling from the anode towards the cathode, he called them as anal rays. Okay, this one is cathode. It was connected to a battery, already we had done in the previous class. Okay, so this one is called cathode, this electrode, and this other electrode, this one is known as anode. So the rays which travel or which starts from this plate, this electrode, that is anode, they are called the anode rays, or the other name which is mentioned in the book is canal rays. These rays were found to be made up of positively charged particles, and since they are positively charged particles, they were also called positive rays, or the other name is, they are also known as protons. Now what are the properties of these anode rays which are being produced from the anode and traveling from the anode to the cathode, that is to the direction which is opposite of cathode rays that we had studied earlier. So what are the properties of these anode rays? Number 1, they consist of positively charged particles, means the charge which is present in these rays is positive charge. Number 2, this get deflected by electric and magnetic field. If you put an electric or magnetic field, like this side positive charge, this side negative charge, because they are positively charged, these rays will get deflected towards the negative terminal of the magnetic field, because opposite charges will attract each other. And third one, the ratio of charge by mass, E means charge, M means mass, vary with the nature of the gas which is present in the discharge tube. Like whatever is the ratio of charge by mass, it will be different for different types of gases which are being filled inside this discharge tube. And the fourth and the last properties of anode rays is these rays produce a fluorescence on a zinc sulfide screen. If you put a screen made up of zinc sulfide, then it will produce fluorescence, means shining will be there in that screen. Now what are the properties of protons? Protons are actually this anode rays only, isn't it, which has positive charge in it. Experiments have shown that the charge by mass ratio depends on the gas which is used in the discharge tube. Since hydrogen is the lightest element, its mass is the lowest and the charge by mass will be the highest. So if we take hydrogen gas inside the discharge tube, then charge by mass ratio will be the highest. Goldstein gave the name proton. So it was Goldstein, the name of the scientist, who gave the name proton to these positively charged anode rays, okay, which are produced. Positive rays which are produced by the hydrogen gas being filled inside the discharge tube. Now what are the properties of protons? What properties they carry, these protons? Number one, some properties are listed in the book. It has a unit positive charge and the value of this charge is 1.602 into 10 to the power minus 29 coulombs. 19 coulombs. See, coulombs is the unit of charge. Then we have number two, its mass, that is the mass of protons, is same as the mass of hydrogen atom, that is equal to, the second property is 1 AMU. AMU stands for atomic mass unit, which is taken as 1.672 into 10 to the power minus 24 gram. 1.672 into 10 to the power minus 24 grams. So that is the mass of one proton. Okay. 1 AMU is 1 by 1837 times the mass of one electron. So first property is the charge of proton is 1 unit positive charge, or we can take it as 1.602 10 to the power minus 19. C means coulomb is the unit of charge, and the mass is equal to 1 AMU, atomic mass unit, and it is considered as 1.672 into 10 to the power minus 24 gram. The third property is the proton is present in the nucleus of an atom. So it is found, proton is found in the nucleus of an atom. Alright? In the nucleus, that is the central part of the atom. So proton is defined as a fundamental particle which carries one unit positive charge and has a mass nearly equal to that of one hydrogen atom. So we denote proton as P1 plus 1, that is charge is plus 1 and the mass is also taken as one atomic mass unit. Okay. Now next one we have the discovery of neutron, Chadwick's experiment. This neutron was discovered by Chadwick, James Chadwick, in 1932. A new fundamental particle called the neutron was discovered by artificial transmutation of atoms, and it was named neutron because it is present in the nucleus and it has neutral charge. And neutron has no charge. So remember, electrons are negatively charged, protons are positively charged fundamental particle, whereas neutrons are neutral charge, means they do not carry, they have neither positive charge nor negative charge. They are neutral in charge. Okay? Protons and neutrons they are present in the nucleus of the atom, and the electrons revolve around the nucleus, that is in their fixed path, which is known as orbit or shell. Now next, atoms, all the elements contain neutrons except hydrogen atom, which has not any neutron. Why? Because in hydrogen the atomic number is 1. It means number of proton is equal to 1, number of neutron equal to 0 inside the nucleus of hydrogen atom. And because proton is 1, so it will have one electron in the first orbit, which is known as K. Now next is properties of neutrons. Like we have studied the properties of electrons, protons. Now the properties of neutrons. First point is they are electrically neutral particle and the mass of neutron is 1.675 into 10 to the power minus 24 grams. So this is the mass of one neutron. 1.675 10 to the power minus 24 grams. Okay, this is the mass of neutron is. Now next one, number 2. Neutrons are highly penetrating. Penetrating means these rays can enter inside certain objects. And they are less penetrating than the cosmic rays which are produced from the universe. That is from the solar radiations and other harmful radiations. Neutrons are unable to ionize a gas. Ionize means to break the gas into their constituent ions. Like hydrogen ion, oxygen ion, isn't it? Now next we have a neutron may be defined as a fundamental particle that has no charge. It has a mass equal to that of hydrogen atom or same like that of proton, and it is represented as, how to write a neutron? A small n we write, that is the symbol of neutron. The mass is 1 and here the charge we take it as 0. That is no charge it has, it is neutral. So 1 N 0, this is the symbol of neutron. This is how we denote a neutron. The discovery of neutron helped a lot in calculating the mass of an atom, because you know atomic mass is calculated, that is atomic number is same like the number of protons present in the nucleus of an atom, but atomic mass is equal to number of protons plus number of neutrons which are present inside the nucleus of an atom. So whenever we have to calculate the atomic mass, we should add both the protons and neutrons which are present inside the nucleus of an atom. Like example, what is the atomic mass of oxygen? Oxygen has how many protons? It is equal to 8, electron is also 8, neutron is also 8. That is atomic mass of oxygen is equal to 8 protons and 8 neutrons, that is equal to 16 grams. Okay, so 16 will be the atomic mass of oxygen. Similarly, mass of hydrogen is 1 plus 0, that is 1 only. Now next is the mass number of an atom accounts for the mass of an atom in AMU, which stands for atomic mass unit. So important characteristics of electrons, protons and neutrons is given in the tabular form. You can learn and write the table in which the mass, symbol and the charge is written of all the three fundamental particles. Okay. So now next that we have to do is discovery of nucleus. Okay, now look at the diagram which is there on the board. Discovery of nucleus, Rutherford's model. Ernest Rutherford, a British physicist, in the year 1911, British physicist Ernest Rutherford, he discovered the alpha particles. That is he discovered that the central part of an atom called the nucleus. Now what he had done, this is the source of alpha particles, that is the source from where alpha particles are produced. These are the alpha particles, okay? So source of alpha particles. Now what is this alpha particles? If asked, what you will say? It is a helium ion. Alpha particles means He, that is the symbol of helium, 2 plus charge, helium ion it is called. Or a helium atom from which the 2 electrons have been removed, that is called alpha particles. Got it? So when from this source the alpha particles are produced and they pass through a thin gold foil. This is written here, thin gold foil. Foil means just like the silver foil is there which is used to cover the sweets and all. So thin silver, not silver, the gold foil is there. Through this gold foil, this alpha particles is made to pass. When they pass, 99% of the rays, that is the alpha particles, pass undeflected, means they will pass through the gold foil without any deflection. This one shows deflection, change in the path. You can see how the deflection occurs, like this one going straight, no deflection. This ray also alpha particle going straight without any deflection. But some of them are completely turning back and some of them are getting deflected. So 99% of the alpha particles pass straight through the atoms of the gold foil, that is the gold atom. Okay. So what is the experiment you want to say? A few are deflected fairly very large, like this much deflection is there, and some of them are deflected back in the same path, that is they return back to from where they are coming. Okay, like this they are coming here back. Some of them are going straight, some of them are deflected. Now what does he want to say, or what is the conclusion that he had drawn from this experiment? The conclusion that he draw based on the observation of his experiment, Lord Rutherford had made or deduced the following conclusions. Conclusion number A: as most of the alpha particles pass through the gold foil undeflected, means without any change in their path, it means the large amount of space in an atom is empty. Like you know that in an atom the nucleus is present in the center and then we have the orbits, so this much space is empty inside the atom, through which these alpha particles can pass straight without getting deflected. Okay. Now next, the second point, most of the volume of the atom is just empty space. This is the first result that he got, that in an atom the large amount of space is empty. Number 2, that is B, as some of the alpha particles are deflected in large angle, like this one you can see, it is making such a great angle while getting deflected. Instead of going straight, it is deflected and making a very large angle. It is because nucleus is positively charged particle and positive, the alpha particles are also positively charged. So you know that when the like charges are brought together, they will repel. Okay. Positively charged zone is responsible for the deflection of alpha rays, that is nucleus, which is also positively charged because it contains protons. So when positive and positive charge are coming in contact, they will get deflected away from each other. Like try to bring the positive or the north pole of a magnet, they will not get attracted, they will be deflected. Similarly, if similar charges are brought together, they will be deflected here. They are not getting attracted because we know opposite charges attract each other, but similar charges will repel each other. So here the similar charges of alpha particles is also positively charged, nucleus is also positively charged. That's why they are deflected. The alpha particles are deflected, forming very large angles. Okay, this is the second deduction. And third point, as the deflection was experienced by very few alpha particles, means only some of the alpha particles were deflected, not all, because 99 point in the beginning only I said 99% of the alpha particles went without any deflection. They passed through the gold foil. And gold foil is made up of gold atoms, so that has been shown here. This is the nucleus and this is the atom structure. So when 99% is passing without any deflection, means the space occupied by the nucleus is very small as compared to the size of the atom. Understood? This is the next conclusion here drawn. And the next one, since alpha particles which are denser are deflected, they completely bounce back. Means some of them are completely returning back. You can see this one is going straight, again coming back. It means those alpha particles which has hit or which will strike the nucleus, they are completely deflected back. Understood? Means they have struck the nucleus of the atom. So the third point says that bouncing back by the nucleus shows that almost the complete mass of the atom must be within the nucleus, and it is correct. The mass of an atom is present inside the nucleus, because when we calculate the atomic mass, we have to add the number of protons and neutrons which are present inside the nucleus of an atom. So according to Rutherford's model of an atom, the atom consists of only two parts, one centrally positively charged nucleus and the other one that is negatively charged electrons which are present here outside the nucleus, which is called extra nuclear electrons, because nucleus is not present inside the, electrons are not present inside the nucleus, so they are called extra nuclear electrons. So according to Rutherford's model, the atom consists of a positively charged central sphere called nucleus, and the electrons which are negatively charged revolve around it. Okay. Now next is, as electrostatic force of attraction which arises due to attraction between oppositely charged electrons and protons. You know that electrons are negatively charged. The protons which are present inside the nucleus is positively charged. Yeah. You know that the electrons are negatively charged and the protons which are present inside the nucleus of an atom are positively charged. So there will be attraction between them, the opposite charges. So due to this electrostatic force of attraction, this attraction arises due to oppositely charged particles. What will happen? It will act towards inside and balance the centrifugal force. Now the force which is present between them, that is electrons and protons, is called electrostatic force of attraction, and centrifugal force is the one which arises due to rotation of electrons. Because the electrons are rotating, I will rub it. The electrons are rotating here around the nucleus. So the force which is developed due to this rotation of electrons around the nucleus towards outside, this force is developed outside. It is called centrifugal force. So one force is acting outward and this force is acting inward. So both the forces will try to balance each other. So electrons are prevented from falling inside the nucleus. So Rutherford model can be compared with the solar system, in which the sun is present in the center of the solar system and rest all the planets revolve around the sun in their fixed orbit, which is known as orbit, isn't it? Now next, a major drawback of Rutherford's model is that it does not explain why the atom is stable. The stability of the atom is not explained. So we know that if any particle moves in a circular path, then its motion is said to be accelerated. That is, if any object moves in a circular path, its motion will increase. Accelerated means its motion will increase and it will start radiating energy also, means it will lose some energy while moving in a circular path. So as it will lose energy, the electrons will keep on falling inside the nucleus of an atom. So this will lead to all the nucleus jumping or falling inside the nucleus of the atom. This means the motion of electron revolving around the nucleus will lose their energy by accelerating it, and the orbit of the revolving electrons will keep on becoming small and small, and finally all the electrons will be present inside the nucleus. It will fall into the nucleus. But this actually does not happen and the atom is stable. So Rutherford model could not explain why the atoms are stable, or the stability of atoms was not explained. Now next model that we have to study is Bohr's atomic model. Okay, the next one is Bohr's atomic model. This was given by a Danish physicist, Niels Bohr, in the year 1912. This scientist also gave a model of atom to explain the stability of atoms. What he said, he gave an explanation of stability of atom. So basic postulates or the main points of Bohr's atomic model are: number one, an atom consists of the points which he said. An atom consists of a small, heavy, positively charged nucleus in the center, which is surrounded by, it is positively charged, okay, it is surrounded by the path which is known as orbit or cell. Okay, the electrons in an atom revolve around the nucleus in circular path which is called orbit or cell. The name is orbit or cell, S-H-E-L-L, cell. Okay, and each orbit has definite amount of energy present in it. Hence it is also called energy level or energy cell. So if asked why the orbit is called energy level or energy cell, because the answer is each and every orbit is associated with a particular amount of energy. That's why it is called energy level or energy cell. Then the second point, So what is the first point of Bohr's atomic model? An atom consists of a small positively charged central part called nucleus, in which the protons and neutrons are present, and the electrons revolve around this nucleus in a path which is called orbit or cell, and each orbit or cell has a fixed amount of energy. That's why the orbit is also called energy level, or it is also known as energy cell. Now the second point which is said was, each and every orbit he gave certain names, or he designated them by certain alphabets. Like this is the nucleus. The first orbit is called K, the second orbit is called L, the third orbit is called M, the fourth orbit is called N. So K, L, M, N, O, P, like this he gave the name. Okay. So K, L, M, N, O, and this is the first orbit, number K, L is the second orbit, M is the third orbit, N is the fourth orbit. Okay. Starting from the innermost cell, which is the K, and the outermost it will be N, O, P. You can keep on increasing it. Now the third point, number 3 of Bohr's model is, as long as the electrons remain in a particular orbit, like if some electrons are present in the first cell, it will not lose or gain energy. But if the electron will change its position, like if some electron will move from the first cell to the second cell, if any electron jumps, it can be done. When the electron jumps from inner cell to outer cell, it absorbs energy, and then so by absorbing energy, absorption of energy will be there, because to change the energy, to change the orbit, it needs certain energy, so it will absorb. And when some electrons will jump from the outer cell to inner cell, it will lose the energy, it will radiate the energy. So thus he explained the stability of the atom, that how the electrons change their orbit. By absorbing energy, they jump from inner cell to outer cell. By losing energy, they jump from outer cell to inner cell. Okay. So an atom is electrically neutral. Why? Because the number of electrons in the orbits, if there are 6 electrons in the orbits, there will be 6 protons inside the nucleus of an atom. So 6 protons, that is positively charged, and 6 electrons in the orbits. If both of them are added, they will cancel the charges, opposite charges, and thus atoms are electrically neutral. So you have understood this one. Now next we have atomic number. What is atomic number? The number of protons present inside the nucleus of an atom is called atomic number, and it is denoted by the capital letter Z. So Z is equal to number of P, that is protons, that is same as the number of electrons. So Z equal to P equal to E also you can write. Okay. Now next one is mass number. Mass number is denoted by capital letter A, and it is equal to the number of protons plus the number of neutrons. Okay, so if you know the protons and neutrons, you can calculate the mass number also. Now atomic number plus number of neutrons is equal to mass number. Atomic number, what is atomic number? Z. So you can write, instead of P, you can write Z also. Okay, that is atomic number plus the number of neutrons. This also you can write atomic number plus the number of neutrons, because number of protons and atomic number are same, so you can write this way also. Okay. So next we have electron distribution in the orbits. You know how the electrons are distributed in different orbits of an atom. Electrons are distributed in the orbits of an atom by following a rule which is called, the formula which is used is 2n square. Okay. You know that electrons revolve around the nucleus. The first energy level is the K cell. Second energy level, that is the second orbit, is L cell. Third energy level, that is the third orbit, is the L cell. So K, L, M cell. So like that. Now I'll say that formula, the distribution of electrons in different cells of an atom is governed by certain rules. Rule number A is the formula 2n square. Now what is the meaning of this formula? Okay, let's see. The different orbits are K, L, M, N. This one, N stands for number of cells. Okay. So here N is 1. First cell it is. This L is the second cell. M is the third cell. N is the fourth cell. So using this formula, let's see how many electrons can be accommodated in each orbit. So if you take the first one, that is K cell, how many electrons will be there? 2 using this formula. Into N is 1 here. So 1 square, that is equal to 2 into 1 square is 1 only. So that is number of electrons will be 2. In the first orbit, maximum 2 electrons can be accommodated. Second is the L cell. Let's see how many electrons will be there in L orbit using this formula. So 2 into L means that is the second cell. So 2 square. Instead of N we are writing 2 because it is second cell. So 2 square is 4. So 2 into 4, that is equal to 8 electrons will be there maximum in the second cell. Like this in the third cell, that is M, 2 into 3 square. So that is equal to 2 into 3 square is 9. It will give maximum electrons will be 18. Like this fourth one, that is the N orbit, KLMN. So here it is 2 into, it is 4. So 4 square, that is equal to 4 square is 16. 2 into 16 is equal to 32. It means the number of electrons will be 2, 8, 18, 32 in the first, second, third and fourth cell of the orbit of an atom. Okay. Now second one, the first rule is this one, 2n square. But generally we do not follow this one, that in third orbit also we write 8. So that is the second rule. The maximum number of electrons in the outermost cell is 8. We never take it as 18 and 32. Okay. And in the penultimate cell, that is the second last cell, is 18. Second last cell will be having 18 electrons and the last cell will be having 8 electrons. Means after 18 we cannot write 32. After 18 the maximum electrons will be 18 only in the last cell. Okay. And in the outermost cell it will be 8. So 2, 8, 18 you can write, but 32 you will not write. It is not necessary for an orbit to be completed before another is formed. A new orbit begins when the outermost cell attains 8 electrons. So it's not necessary that if 18 electrons can be accommodated, means we will keep on filling 10, 8, 9, 10, 11, 12 electrons in this orbit. No. We can shift them after 8 to the next orbit or to the next cell. So distribution of electrons in the atoms of elements having atomic number 1 to 20 is already given there. So you can practice it. I will say one example. Let's see which one will do. Calcium. Okay. Calcium symbol is Ca. Let's see how the electrons are distributed. What is the number of atomic number of calcium? It is 20. So you have to distribute this 20 electrons in the different orbits. Okay. First orbit 2, maximum 2 can be there. Then second orbit 8, 2 plus 8, 10. In the third orbit, how many will be there? 2 plus 8, 10. 10 plus 8, 18 and 2. I am not writing 18 here. See, I am writing 2, 8, 8, 2. According to this formula, 18 can be accommodated here. Means in this one I can write 2, 8, 10. Here 10 I can write. But no, will not follow. The second rule says that maximum 8 should be there. And after that we can shift the electrons in the next orbit. Got it? Here also we are not writing 32. First, second, third cell. 18 should be there. But we are writing maximum 8. After that shifting in the fourth cell. Got it? So in this way you practice writing the electronic configuration and try to draw the diagram of electronic configuration also. Like one diagram I will show you. Rest on as homework you can try. Is already there. Diagram of atoms of first 20 elements. Electronic configuration can be shown with atomic diagram. So I am showing atomic diagram. This is electronic configuration. So let's do of calcium only. Okay. How to do it? First you draw the nucleus. Number of protons how many? Number of neutrons how many? Protons how many are there? It is 20. Number of neutrons how many? 20 only. Okay. First orbit you draw. You see the nucleus you have to write. 2 electrons are there. Draw the second orbit, that is the L. How many? 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now third orbit, how many electrons are there? Again 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now fourth orbit is also there. How many electrons? Only 2. So 1, 2. Finished? Like this. This is called the atomic structure of calcium. In the same way, as homework, you practice writing the electronic configuration of the first 20 elements of the periodic table, as well as drawing the diagram, atomic structure of the first 20 elements. In your copy, you can do it as homework. Okay? After watching the video, you can like and comment. Write your comments in that section. So next, in the next class, we'll study about the valence electrons, octet rule, isotopes, then the chemical bondings and all. Okay? Thank you.